I beg your pardon?
Can you see the screen share?
Boleh.
Yes, madam.
Okay, so if you want to ask where are we now, this one is exercise number 2. So after the video degree of dissociation, ada juga yang belum siap video belum siap at puzzle. So if you look at this one, I can see a few class lah. So this one is whose class is this? MS8 ada 3 orang belum siap. MS, this one MS, tak tahu nama. MS9 is it? This one is MS8 to off lagi. Dekat sini ada juga lah yang belum siap MS7. MS9 I think is already done. Okay, so you proceed with this one. Those whose name is written over here. That means you never watch. I can see your progress from here. Okay, I can see your progress whether you have watched the video, whether you have answered the questions given. So please watch through the video and then try to attempt the questions. So this one has some typing error. Should be 28th of October. Okay. So in your exercise number 2, you are being instructed question 1, 4, and 9. So let's just look at question number 1 here. Okay, you can check the answers together with me. So in this question, it says that the temperature 668 Kelvin. So this one is already in the correct unit. And then you are given the number of mole of COCl2. So there's a keywords here for you. No number of mole, you can write down the abbreviations, number of mole. So are introduced into an evacuated 1.75 liter flask. So of course 1.7 liter refers to the volume. Okay, I want you to pay attention to this sentence. Introduced to an evacuated flask. That means this is at the very beginning of your reaction, initially. Evacuated, it means it is empty flask. So at the very starting point. Okay, so from here, you got temperature, you got number of mole, you got volume. Okay, and then missing one more information. So you look at the next sentence, it will tell you about the clue. At equilibrium, okay, the total pressure of gaseous mixture is 32.4 atm. So this is the total pressure at equilibrium. So the question is asking to calculate for Kp. So very obvious, you need to use the quantity of partial pressure in your ice table. Dia sudah minta Kp dan boleh juga partial pressure. Alright, so to find the partial pressure, alright, we need to use the ideal gas equation PV equals to nRT. Using each of the information given, temperature, number of mole, and also volume. Okay, since the number of mole of our CO and Cl2 are the same, so you can calculate the partial pressure of CO. This one is at initial, yeah? At initial, the partial pressure of CO is the same as the partial pressure of Cl2 because number of mole are the same. Okay, so nRT over volume, which give you 1 times 0.0802, 0.8206. Temperature is already in Kelvin, and the volume 1.75. Okay, managers want to make sure everyone can follow until this part.
So basically speaking, at initial we just we directly calculate for both carbon monoxide and the chlorine, isn't it?
Yes, using PV and RT. We're just extracting the information stuff because we want to use partial pressure inside ICE table.
So
So
we use
everyone is good with,
this.
is it everyone good with PV and RT?
So we use this jalan kerja just because both of the species have the same mole.
Yes, if it's different mode, then you separate. You separate it. Kalau nak separate kan pun boleh, tak ada masalah. So
Oh,
maksudnya
so
awak
we
carikan
can.
PCO one part and then PCl2 one part.
Oh,
Kalau
so can
sama
two
boleh
in one
macam ni
lah.
lah. No problem.
Okay, okay. Okay,
So
madam.
in this case, you will get your partial pressure 31.3235. Don't forget about the unit. Okay, is everyone all right?
Yes, madam.
Okay. So in these questions, you're not giving any equation, isn't it? So we need to construct our own equation. Okay, but these equations have already shown in the previous example lah. So I hope you know how to construct the equation. So you got CO, you got Cl2. Okay, so it's carbon monoxide gas. Okay, in chlorine gas. In equilibrium, what will be your product? It's the same as the previous example in the video, yeah? Carbon CO, Cl2 in equilibrium with,
Cl.
okay, CO, Cl2 gas. We're just adding up together. And then please also check whether the equation is balanced or not. Okay, and then in these questions, as we say just now, we want to calculate Kp. So in your ice table, the quantity will refer to the partial pressure straight away. Okay, so we have the initial partial pressure in ATM. We got the change in partial pressure, ATM. And the last one, we have pressure at equilibrium, also in ATM. This one is your ICE, initial change equilibrium. So it depends on what quantities do you have. Okay, and then we fill in the blank. So at initial partial pressure of CO, 31.3235. Chlorine gas also the same, 31.3235. Is there anything for your product?
No.
Then you put as 0. So we say introduced and evacuated. That is the initial partial pressure. No product yet. No reactions yet. Okay, so the change in pressure according to your balance equation, your stoichiometry ratio, CO will minus 1x. Cl also minus 1x. Why negative? Because your reactor will decrease over time. Okay, concentration of partial pressure will decrease over time. But for your product, when the reactions happen, your partial pressure will increase. So again, this one is the stoichiometry ratio. So you will only plus 1x. Until this part, everyone can follow.
Can,
Yes.
madam.
Madam, can you repeat on the second column? On the one
Okay,
that negative
so
x,
the
negative
second
x, and
column,
positive x.
why negative x? Because
Hello.
reactant, the pressure will decrease over time. Therefore, we put negative. Why only 1x is because of your balance equation. Stoichiometry ratio is 1, 1. Therefore, you only minus one single x. Okay, same thing goes to your product. Product pressure will increase over time. Therefore, you have a positive sign. Stoichiometry ratio 1, so plus only 1x. So it depends on your balance equation. And then we will add them up together in the equilibrium pressure over here, 31.3235 minus x, 31.3235 minus x, and over the product here, you have the x value. Okay, so we come back to our questions over here. Total pressure at equilibrium is 32.4. So that means in this column, the total pressure at equilibrium, CO plus with Cl2 plus with the product, everything add up together will give you 32.4 ATM. So this is the very important clue for you to figure out what is the value of your x. Then we make one equation. Okay, so total pressure equals to the pressure of CO, pressure of Cl2, pressure of the product CO, Cl2. So that means you add up together. So this total pressure happens at equilibrium. Nak tulis pun boleh. Supaya awak faham lah dekat sekarang kita kira dekat mana. So equilibrium total pressure 32.4. Then you just add up together individual partial pressure. PCO, PCl2, 31.3235 and plus X. Okay. So, bila awak kira nanti, awak akan nampak value X terus. Yang ini bukan quadratic and they're straightforward. Just be careful with the positive sign, the negative sign here. And what values do you find for the X?
$15.124.
30 point?
15.124.
15.124. I think you have divide by 2.
30.4. 30.2.
30.247. Kira satu persatu lah. So, kita akan tambah. Bila awak buka bracket, awak akan nampak. So, X, this one minus X, this one plus X. So, that means your X is gone. So, the whole equation just remain with one X. So, boleh kira balik Arvin. So, X values over here, you will get 30.247. ATM also lah. Okay. Sampai sini ada masalah tak? Nak Madam show step. Does everyone get this value?
Hello?
30.247.
Yes, madam. Putus lagi ke? Hello?
Yes, Madam is here.
Hello?
Alright, so after
Sorry,
you have
madam,
got
terputus
the
lagi.
value of 30.247, okay, 30.247, you can fill it inside your ICE table. So that means you use 30.3235 minus the value of X, 30.247. Then you will find the equilibrium partial pressure equals to 1.0765 for CO and also for Cl2. So 1.0765. And of course, the value of X, 30.247. Is everyone good under this part?
Yes, madam.
Yes, madam.
Boleh ya? Okay. So the next part come to our final target lah of the questions, which is to calculate. Okay, final part of the questions is to calculate the KP. So of course you need to come up with your KP expression. So KP equals to the product sitting on top. We have the partial pressure of COCl2 over the pressure of our CO and the pressure of Cl2. Do you get the correct expressions for Kp? Do you get the correct pressure for Kp? The correct expressions for Kp.
Yes.
Okay, so we just fill in the values. And remember, K refer to equilibrium constant. Okay, so if you want to find anything related to equilibrium, it should be found for this column E. So we substitute the product 30.247 divide by 1.0765 times with the pressure of CO2, 1.0765 as well. So finally, you will come up with 26.1. You also need to calculate that just in case Madam kira salah. So awak kira juga tengok sama ada kita ada buat mistake ke tak. So you all need to let me know lah. So sometimes Madam make mistake as well. So tadi tengah edit video pun nampak salah. That's why you add puzzle a little bit later. Madam nak re-edit balik video. Okay, so sampai sini dapat tak KP value?
So for the class, madam.
Hmm.
So for the class at 12, so the ED puzzle, you wouldn't be sure if we'll get it at 12.
Hazim, fokus kat sini dulu. Fokus kat sini dulu. Nanti yang madam akan update yang kemudian.
Sorry, madam.
Fokus kat sini dulu. Okay, so dapat tak 26.1?
Dapat.
Dapat.
Okay, everyone's
Dapat,
good
dapat.
ya. I don't just want you to remember, follow the questions. Kalau soalan bagi KC ataupun dia ada information dengan concentration, so I stable awak akan ikut concentration. Okay, kalau dia KP dan awak dapat kira untuk partial pressure, jadi I stable dia akan ikut partial pressure, depends. Okay, untuk soalan 3 dalam app puzzle video hari tu, kita guna number of mole. Boleh juga, number of mole is one of the quantity. Why we are using number of mole? Because of the last part of the questions, we calculated percentage by mass. Siapa yang keliru nanti tengok balik video. Okay, video dalam app puzzle. Ataupun dalam YouTube pun madam sudah upload lah. Okay, so this is the answer for your question number 1. Are you alright for proceed to question number 4? Boleh screenshot kalau untuk sesiapa yang tak sempat nak salin.
Yes, madam. Putus lagi. Nampak.
Hazim, awak tak putus, madam dengar awak lagi. Okay, so question number 4. So we try to interpret the question first, yeah? Right. So the formation of sulfonyl chloride SOCl2 is an isothermic reaction, just an information for you. So you have your balance equations given all are in gaseous phase. So initially you have the number of mole SO2, number of mole Cl2 is placed in a 2.0 liter container. So that means initially you only have SO2, Cl2. Okay, no product. But then at equilibrium, there is 0.046 mole of the product. Okay, at equilibrium, they give you the mole of the product form. So calculate Kp for the reaction. So of course, in the questions, you have the temperature. So you know what to do lah. So question asking for Kp, and then we try to figure out anything we can do to find the partial pressure or not. So we have number of mole, we have the volume, we have the temperature. So information dia cukup. Kita boleh pakai PV and RT. So we try to calculate one by one, yeah. So at initial, so we want to figure out the partial pressure of our SO2. So we try to rearrange PV and RT, give you number of mole SO2 RT over volume. So you try to substitute the values. So number of mole SO2 0.150, gas constant, temperature, because 25 degrees Celsius give you 298.15. And the volume give you 2 liter. So at this part, you need to calculate by using calculator of course. So 1.835 ATM. So madam will pause a while for you to catch up at this one. For those who have already done, please mark on your own answer. So PV and RT, calculate the values of partial pressure. And you can also check the partial pressure for another reactant Cl2. So number of mole Cl2. So madam doing this one, you can check on your own. So 0.350, gas constant, temperature, volume. Okay, calculate. If see you can you get the same answer as madam or not. Madam bagi sikit masa awak kira dulu. Let me know if you need help, sir. Just a curious question. So now madam is using another, I'm using handphone to connect to my headset. Did you see my face during my explanations or not?
I beg your pardon?
Yes.
You see my
Yes,
face,
madam.
Previously? No.
Yes.
Why?
Previously also see. Because madam is connected using handphone, previously using laptop. So madam tak selesa lah kalau talking to the laptop only. So at least I can see a camera, I can see myself. Shock sendiri sikit. Okay, so everyone can follow up until this point.
Yes, madam.
Okay, untuk sesiapa yang cepat, madam minta maaf because we have to wait for your classmate who can't follow. So I will slow down a little bit in the walking steps. Okay. And then after you have found your partial pressure of the reactant, then we proceed to the second sentence. At equilibrium, 0.047 mole SO2Cl4. So I will jot down in my working step. This one doesn't have any marks lah, but then you will be a little bit clearer. What are you finding? What are you calculating? Okay, so same thing, PV and RT, but this time we are finding the product. So number of mole of your product, RT over volume. Okay, so 0.047, gas constant, and temperature. And then divide by the volume to get the partial pressure, 0.575 atm. So you have to clear the first two partial pressure is at the very beginning. Okay, and then the third partial pressure is for the product at equilibrium. Okay, once we have found, then you know that in order to calculate for the Kp, we need the equilibrium partial pressure. Therefore, you need to use I stable. So we have our SO2, we have our Cl2 in equilibrium with the product SO2, Cl2 gas. I stable always have the equation on top. And then we are using the initial pressure in atm, change in pressure, equilibrium pressure. Okay, and then just fill in accordingly. 1.835, that is initial concentrations of SO2. So you fill in at this column, at this box, 1.835. 4.282, that is the initial pressure for chlorine gas. So 4.282. Anything from the product at the initial? Anything I need to fill in this part?
Ada zero.
Zero. Tak ada product lagi lah. So, kosong. Okay, so the change in partial pressure, follow ya. Stoichiometry ratio 1, so minus 1x. For chlorine also stoichiometry ratio dia 1, so kita tolak 1x. For SO2, Cl2, yang
Plus
ini
X.
adalah plus X. Yang ini contoh kalau let's say Madam dapat 3 SO2 Cl2. So that means over here you need to plus 3x. That one is follow your stoichiometry ratio. Contoh lah yang ini. Tapi untuk jawapan ni bukanlah. Dia satu coefficient saja, so kita tambah 1x saja. Okay, and then equilibrium partial pressure, you just add them up together. 1.835 minus x, 4.282 minus x. Okay, Madam rasa ada orang yang confused macam mana nak dapat equilibrium concentration, Madam tunjuk contoh. So this one plus this one add together give you the equilibrium concentration. This one plus this one add together give you the equilibrium concentration and so on. So of course, at your products over here, 0 plus x give you the value of x. Siapa yang confused dekat part sini, please correct your misconception ya. Okay, so we back to the equilibrium partial pressure 0.575, which is equals to your equilibrium partial pressure SO2 Cl2. So if you want, you can straight away fill it inside your ice table. So maksudnya awak terus dapat dah value X. Is everything good? Okay, sampai sini okay tak?
Okay, madam.
Alright. So kalau okay, kita kira lagi. Okay, untuk equilibrium pressure for your reactant. So maksudnya reaction ini belum habis. Kalau awak masih nampak values lagi, maksudnya dia masih ada reaction lagi. Equilibrium bukan maksudnya tamat lah. Equilibrium, that means your reaction is still ongoing. The reaction doesn't stop. So 1.835 minus the values of X that you have found here will give you 1.26. Okay, that is the partial pressure of SO2 at equilibrium. Okay, similar for Cl2, 4.282 minus X will give you the value 3.707 at equilibrium. Okay, so kita keluarkan expression untuk Kp pula. So don't forget partial pressure using the symbol P. SO2 Cl2. And then for the reactant, SO2 times with Cl2. Kenapa madam buat dekat sini terus tak ada power? Sebab equation awak memang tak ada stoichiometric coefficient other than 1. Semua adalah 1, 1, 1. Therefore power dia pun semua adalah 1. Dia depends kepada balance equation awak. Okay, so after you have getting the expressions of Kp, then you substitute the values. Product pressure, reactant pressure, 1.26 times with 3.707. And you roughly get this answer. Try to key in your calculator and see whether you get the same answer as madam or not. Dapat jawapan?
Dapat, madam.
Dapat, madam.
Dapat, madam.
Faham?
Madam.
Boleh catch up ya?
Boleh, madam.
Okay, so yang ini contoh untuk soalan yang bukan concentration. So that means we have to refer to partial pressure. And also you need to take note on the phase lah. In this case, all gaseous phase. So partial pressure memang untuk semua species yang ada. Okay, so if you want to snap a picture, you may do so. Okay, we proceed to our next questions, which is question number 9. Okay, so in these questions, I just want to confirm back with you. Is it concentration or partial pressure we need to use? Anything? Any guess? Partial pressure or concentration? Which one we want to use?
Concentration.
What do you think so, Sue?
Because the information given is about the mole and the volume. If we divide the mole by the volume, we get concentration.
Okay. One more clue. Ada satu clue lagi. Tengok pada soalan. Sebab soalan ni dia hanya bagi tahu equilibrium constant. It's only say equilibrium constant. We only know this value refer to K. So whether it's Kc or Kp. Anyone want to have a
Degree
guess?
of dissociation.
The temperature?
Temperature?
Temperature
Temperature
is
doesn't have
given?
any clue.
Ah, no ah.
Degree
Oh, okay.
of dissociation.
Degree of
Dissociation.
dissociation. So degree of dissociations refer to the change in concentrations. Actually, for these questions, it can use partial pressure or concentration. Both will be correct. Okay, but then we choose the easiest one. Degree of dissociation refer to change in concentration over initial concentration. So we use concentration in our ice table. Okay. So number of mole given, your volume is given. So the number of mole of Cl2 and PCl3 form at equilibrium is your first questions, yeah? So in your ice table, we want to convert into the concentrations first. So we fill in over here initial concentration, number of molar, change in concentration, molar, and then equilibrium concentration. Okay, and then you need to come up with the equation. So in these questions, we have our initial reactants PCl5 gas. So decompositions of PCl5 give you, soalan pun bagi clue juga kan. So decompose into what product? Decompositions of PCl5 will form
PCl3 plus
PCl3 plus
plus Cl2.
Cl2.
very good. So the clue is given in the question. So it will form Cl2, your chlorine gas, and PCl3 gas. So you have three species in this example. So initial number of mole. Nak kira pun boleh, tak ada masalah. Tapi dia straightforward because 1 liter. So anything divided by 1 equals to the same value. So 5 divided by 1 give you 5 molar. Okay, so 5 over here, 5.00 lah. I follow the decimal place given in the questions, yeah? And then at the beginning, you don't have anything from the product. So according to the balance equation, we need to minus x for for the reactant. We will plus x for the product. Okay, because the stoichiometry ratio is 1, so everything is just using one single x. Then we can find out 5.00 minus x, and then for Cl2 x, for PCl3 also x. So sampai sini boleh ikut?
Boleh, madam.
Boleh.
Okay.
So,
So we
okay.
want
Okay.
to find out the x value. If you want to know what is the number of mole of your product Cl2, PCl5, so first of all, you need to calculate the concentrations or the value of x. So you need to come up with your Kc expression. So ini madam rasa awak boleh buat sendiri kan, concentration product over concentration reactant. Tapi kena guna formula jangan guna perkataan product reactant. So PCl5. Okay, and then you can calculate for the value of x by solving your quadratic equation. So Kc, we have the value 0.40 given in the questions already. Okay, and we have the concentration Cl2 equals to x, PCl3 also x. So given over here x squared. Okay, and then your PCl5, 5.00 minus x. So solving your quadratic equation. Madam faham ada there are some of you who are very weak at quadratic equation, so you need to take time to solve your quadratic equation. But this one is considered a simple one lah. Okay, so you find your values x Madam bagi jawapan dulu. Awak check sama ada awak dapat value X ini tak.
Got the same answer, madam.
Got it? Yang lain ada masalah
Yes,
tak
madam.
untuk solving quadratic? Yang lain dapat tak?
Dapat, madam.
Right, madam.
Okay. So, if you still remember, right, if you got two value of X, what should you do?
Choose positive value.
Mm-mm. Is it the positive values only? That is not that is the concept, yes, but that is not the answer. You need to try and error, substitute into the concentration. Kita nak concentration positive, bukan value X positive. Okay, kita nak concentration dia positive. Concentration tak boleh negatif, bukan X tak boleh negatif. Kena bezakan ya. What if later in the objective question it asks the reason how to choose the X, for example lah. So in this case, your value of negative 1.6283. Sebab madam risau kalau kedua-dua X awak dapat positif, macam mana awak nak buat? Kalau dapat negative, of course lah, when you substitute over here, you see the negative value. So of course, this one will be wrong. But what if you get two positive value of X? Then you need to substitute to get a positive value of the concentration at equilibrium. So dalam awak punya jawapan dalam act puzzle, siapa yang tulis positive value, madam nak awak refer positive value of what? Is it positive value of concentration or positive value of X? So in this case, you have to write down also lah, which value you need to ignore. Or you want to write down not valid, can also, as long as you know which value we will not take it. Okay, so back to our questions, we want to find the number of mole of Cl2 and PCl3 formed at equilibrium. So of course, in your ice table, we are using concentration. So concentration Cl2, concentration PCl3 sama dengan value X sama dengan 1.2283 molar. But we want to find the number of mole, and because it is only 1 liter, so anything times with 1 or divide by 1 equals to the same value. So number of mole of Cl2, number of mole of PCl3 equals to 1.2283 mole. Take notes on the unit. Okay, please take note on the unit. Molar refer to concentration, mole refer to number of mole N. Alright, in the video, sometimes madams akan tersalah cakap something. Maybe I'm writing something else and then I say something else. Please pandai-pandai sendiri tukarkan. You know, like sometimes your brain and the mouth is not synchronized. So apa yang madam tulis mungkin dia tak sama dengan apa yang madam nak cakap kan. So you need to pay attention lah. Okay, so is it alright for the first part A to calculate number of mole at equilibrium? Tengok soalan sikit ni. A, number of mole of Cl2, PCl3. Is it alright? Got the number of mole? Liliana say, alright, madam. Thank you for responding. Okay, so we proceed to our part B. We want the degree of dissociation alpha for PCl5. So PCl5 is your reactant. So we have the change in concentration, PCl5. We have the initial concentration, PCl5, and then abbreviation initial. So PCl5, the change equals to only one x, one single x. No need to put in the sign negative. Sign negative refer concentration decrease. So you don't have to put that one. Okay, so 1.2283, the concentration x, divided by the initial concentrations 5, which will give you the value of 0.246. So degree of dissociation, no unit. Okay. So sampai sini
Madam,
ada soalan. Ya.
can you for the B, because I missed it because of internet connection.
You want me to repeat from
Uh, from the start
beginning?
for question B. Yes, question B only.
Okay, so better repeat untuk sesiapa yang lost jugalah. Ya. So 9B,
Sorry,
degree
madam.
of dissociation. Azim, you need to memorize the formula. So degree of dissociation gives you the formula. Change in concentration over the initial concentration. Nak tulis dalam ayat boleh, tapi madam prefer dalam simbol. Easier for you to see. Okay, so change in PCl5 concentration, you can refer to the ICE table. Change in concentration of PCl5 give you only 1x. So over here you only have 1x. Okay, initial concentration is 5. So using the value of x 1.2283 divide by 5 give you the value of 0.246. You got that?
Yes, madam. So basically speaking, no unit, isn't it?
Yes, no unit.
All right.
Okay, nak tanggal gambar boleh ya? So question number 149. Do you have any other question you want to ask? Yang lain boleh check jawapan lah, nanti madam akan upload. Ya, siapa yang cakap ni? Nurul apa?
Ya, Zarifah.
Okay.
Madam, yang soalan nombor 4 tu, kalau kita cari concentration dia boleh tak?
Soalan nombor 4 cari concentration. No problem, you can find concentration, but after that, you find Kc. Then applying the formula Kp equal to KCRT delta N kan? Boleh? Tak ada masalah, boleh. Cuma dia panjang sikit lah.
Lepas tu kan madam, kan soalan apa ni, soalan nombor 4 ni kan dia ada bagi temperature kan. Kalau dekat soalan tu kita tak pakai maklumat yang dia bagi tak apa
Tak apa. Information dia bagi kalau awak nak guna sebab dia ada banyak cara. Like this is one of the way. Sebab madam sudah nampak KP dan dia punya information kita dapat cari partial pressure. So awak boleh terus guna partial pressure dalam ice table. Kalau awak tak nak, boleh juga kira number of mole dulu. Number mole pula. Concentration dulu. Lepas tu ice table awak pakai concentration. Kirakan KC. Lepas tu convert kepada KP. Jawapan lebih kurang sama. Dia kan beza lah sikit decimal point ke. Tapi jawapan lebih kurang sama. But the working step is slightly longer. Boleh ke ada soalan lagi?
Boleh, madam.
But I want you
Madam.
to try. Yes, so.
Yeah, sorry. Madam, so for 3 of the question, I can use mole in my ice table, right?
Can, but you need the type ice table can use number of mole as well, but you need to remember to convert. Because if you want to use Kp, that means the partial pressure at equilibrium. If you want to use Kc, then will be concentration at equilibrium. You cannot say Kc, then in the substitution you use number of mole, cannot. Because the Kc expression using concentration.
Oh, okay. The formula still needs to like calculate the concentration.
Yes.
Sorry. Madam, and then my next question is, how do we know if our answers is like logic? the number we get, because just now I get 800 and something, and then I'm not like
Quite sure, huh?
yeah,
There's
the
no
range.
certain range. There's no certain range, but I can give you a guideline. KP will normally bigger than what? Bigger than, it's not very small lah, but concentration will be have like times 10 to the power of negative something. KP slightly bigger, 0 point something, 10 point something, 20 point something. But
So
concentration will be
concentration,
smaller.
it will be smaller. We'll got like decimal places.
Yes, but there's
Oh,
no certain range lah.
okay,
You
okay,
said
okay.
usually. So that
Usually.
so does that mean that it's not 100% like that?
Yes, not 100%. I won't give you
So
a very, very confirmed one because there is some exception also.
oh, okay.
Yeah, yeah. I
So,
Interesting.
just want
Okay,
to
okay.
avoid like blunders, and then we are not realizing that we are doing some very huge mistakes.
uh, then try again for your exercises.
Okay.
If
Thank
I
you,
figure
Adam.
out a range, then I'll let you know lah. But so far, KC will be much smaller than KP. Okay. Any other questions before Madam end the session? Ada soalan nak tanya?
No